Welcome to this video lecture on the subject optical and microwave engineering. So in this lecture we are going to discuss about S parameters and properties of S matrix. So first of all we are going to see what is two-port network. So two-port networks are used to represent any device which is having a input port and an output port. So two-port networks are often described by using the Z parameters, that is impedance, Y parameters, that is admittance, H parameters are ABCD parameters. So these are generally used in low frequencies. So low frequency analysis of any network, we are using these two-port network parameters. But in case of higher frequencies, these parameters cannot be applied. So for microwave and radio frequency applications, we are employing the scattering parameters. So because of the drawbacks of Z, Y and H parameters, such as at micro frequency, total voltage and current are difficult to measure, and open and short circuit terminations are difficult to realize in high frequency, and active devices may oscillate when we are doing open and short circuit conditions. So these are the reasons why ZH parameters cannot be used at microwave frequencies. So what we use at microwave frequencies are scattering parameters or S parameters. So here we are going to use incident and reflected waves at the port. So where resistive termination is employed, and active devices are quite stable under resistive termination. So in the two-port network, the parameter is represented using incident and reflected waves. Here the symbols A1 and B1 are used for these wave amplitudes. And S parameters are measured by sending a single frequency signal into the network and detecting the waves that exit from the each port. So we need to consider the power, voltage and current can be considered to be in the form of waves traveling in both the directions. So we are going to measure the S parameters based on the incident and reflected waves. So for a wave incident on port 1, some part of the signal reflects back out of that port, and the same some portion of the signal exit at other ports. So in this diagram we can see there is a reflected wave and there is a transmitted wave. So first look at the S11 parameter. So it means S11 refers to the signal reflected at port 1. So the numbers are same here, no. So the reflected wave at port 1, the incident wave is also port 1. So the scattering parameter is the ratio of two waves B1 by A1, where B1 is the reflected wave and A1 is the incident wave. And the next parameter we are going to consider is S21. So in the scattering parameters, it refers to the transmitted wave. So what we are giving as the input is incident wave at port 1, that is known as the A1, and transmitted wave at the port 2 is B1. So this S21 is the ratio of the two waves B2 by A1. So generally this parameter is a transmission factor. And similarly, for other two parameters, S22 refers to the signal exiting at port 2 when the incident signal at port 2. So that is a ratio of B2 by A2. And also S12 refers to the signal exiting at port 1 for the incident signal at port 2. So it is the ratio of B1 by A2. So like this we can define the S parameters for any number of ports. So for now we considered only port 2, that is a two port network. So we are having four parameters. Generally we will have a 2 by 2 matrix for two port network. So there are four parameters. So a linear network can be characterized by a set of simultaneous equations describing the exiting waves or reflected waves from the each port in terms of incident waves. So this is how we define the S parameters. So these parameters are complex, that is they have magnitude and angle, because the magnitude and phase of the input signal are changed by the network. So these are also referred as complex scattering parameters. And we can form the equation of these S parameters for a two-port network using this relation. Here B refers to the reflected wave and the capital S refers the S parameter and small a refers to the incident wave. So from this we can derive the S matrix. So here the S matrix is given by 2 cross 2 matrix. So for a multi-port network, for example, here we consider the 5-port network. The device has 5 ports. So for this we can write S matrix as 5 cross 5 matrix, and left side of the equation is the reflected wave, and incident wave is denoted in the right side of this equation. So we can derive the S parameters using the relation as S11 equal to B1 by A1. This is the reflection coefficient at port 1, keeping A2 as 0. So when the signal incident at port 2 is 0, we can define S11 as B1 by A1. So this is known as the reflection coefficient at port 1. And for the forward transmission coefficient, it is S21. So here we can define it as B2 by A1 when A2 is 0. So this is the forward transmission coefficient. And reverse transmission coefficient from port 2 to port 1. So that is S12. And reflection coefficient at port 2 is given by S22 with A1 equal to 0. So next we shall see the properties of S matrix, which are very much useful for studying the various microwave passive devices. So the properties are: consider a M-port network. It is always a square matrix with order of M cross M. For a 3-port network, it is an order of 3 cross 3. And next, for a lossless network, the S matrix is unitary. So it means any matrix S multiplied by its complex conjugate gives the value of identity matrix. So identity matrix, we know the diagonal elements are 1. And next property is that S matrix is symmetric for the reciprocal network. If we consider the device as a reciprocal device, so S matrix is symmetric. So we can write the matrix as transpose of the matrix are equal. So S equal to S transpose or Sij equal to Sji, so that we can equate the elements of the rows and columns for the reciprocal network. And for the unitary property, we can write the two types of equation. First one is the summation of Sij multiplied by Sij star equal to 1. It means we are considering the elements of same row and same column. So the value we get is unity. And if we take a different row, Sij, Sik star equal to 0. So we get the answer as a 0 for this condition. So this is the two forms of unitary property. So we can have a small assessment. So what are the drawbacks of ZYH parameters at microwave frequencies? So we know that ZY parameters, short circuit and open circuit condition is difficult to perform at microwave frequencies, and the device becomes unstable. And what is the uniqueness of S parameters? So S parameters are very much useful at microwave frequencies because we are considering the wave amplitudes in S parameters. And properties of S parameters, they are symmetry property, unitary property, and zero diagonal property. So these are the important S parameters. Thank you for listening this lecture.